equilibrium situation on inclined surface, smooth. SIPO applies a force to move a wheelchair down a frictionless ramp of length 10 meters and vertical height of 1,5 meters as shown. The mass of the wheelchair is 20 kilograms. Determine the force applied by SIPO if he moves the wheelchair at a constant velocity. Solution. Before we proceed, let us identify the situation. The surface is inclined. It is frictionless. The wheelchair is in equilibrium state since it is moving at constant velocity. Let us find the forces acting on the wheelchair and draw its free body diagram. The force of gravity, Fg, is acting in the downward direction. The normal force acts perpendicular to the contact surface, that is the plane of incline. Notice that the angle θ at the bottom of the incline is the same as the angle made by Fg with the normal to the incline. We know that the force of gravity Fg can be resolved into two components, the one acting perpendicular to the incline and the other acting parallel to the incline. The plane of motion is along the inclined surface, so the net force in a direction perpendicular to the inclined plane is 0. The component of Fg, parallel to the incline Fgx, will pull the wheelchair down. Therefore, there must be an applied force by SIPO in the opposite direction. That completes our free body diagram. We can apply Newton's second law to the motion of the wheelchair along the incline. Vector Fr equals m vector Ax. Vector Fr is the vector sum of the forces along the incline. Therefore, vector Fr equals vector F applied plus vector Fgx. Taking the direction towards the bottom of the incline as positive, we get vector Fr equals vector F applied plus Fg sine theta. Combining 1 and 2, we get m vector Ax equals vector F applied plus Fg sine theta. Here, the acceleration is 0 since the wheelchair is in equilibrium state, that is, uniform motion. 0 equals vector F applied plus Fg sine theta. Substituting the values, we get vector F applied equals negative Fg sine theta equals negative mg sine theta equals negative 20 times 9,8 times 1,5 over 10 equals negative 29,4 newtons. The negative sign indicates that the force is in a direction opposite to that we assumed as positive. SIPO needs to pull the wheelchair with a force of magnitude 29,4 newtons towards the top of the incline in order to move it down at constant velocity. Note that the arrow for F applied is equal in length to the arrow for the x component of the force of gravity.
Starting to feel it? Now go master it with Messi.